Now we are going to implement the naive Bayes classifier with the help of example, and we are using the wine dataset description. The wine dataset contains the result of chemical analysis of wine grown in different specific areas of Italy. It contained 178 sample data, that means rows, and 13 chemical analysis, that means features or can be said as column, recorded for each sample, and contains 3 classes which are our target value, and there are no missing values. So you can see here in the sklearn about the load wine dataset also. All the description is given about whatever the parameters are there, and the example for loading also is given here. So next we are going to implement it, and firstly what I'm going to do is I'm going to import the libraries which are required. So here you can see that I have imported NumPy and pandas firstly as NP and PD. Next, I have to import the dataset and then load the dataset. So that we are using from sklearn. So I have to write here like this: from sklearn import datasets, and then I have to write that I'm creating a variable naming wine, and there I'm going to load the dataset. And if you want to do this, then you can print it also for checking that what is there in the data set. So this type of array is generated of the data set, and array is having the target values here. You can see class 0, 1 and 2 determining the 3 samples of wine which are there, the target value which are there. Next, what we are going to do is we are going to print that how many features are actually there, what are the feature present here. So for that we simply write like this: print wine dot feature names. So here you can see that it prints the features which are there: alcohol, malic acid, ASH, alkalinity of ASH, magnesium, total phenols, and etc. These are the features which are there. Next, if you want to print the target name, that what are the target labels which are there, so you have to print like this: print wine dot target names. So here you can see that these are the target value, class 0, 1 and 2. Now here we have seen our target data also and features name also. Now what will we do? We will train our data frame according to that. In X we will store the data which are there in the features, and in Y we will store the target name for the predictions further. So for that we have to write like this. Firstly we need to convert it into a data frame. So for that we will write like PD dot data frame and here we have to write wine data we are using here, and then we are going to print the X, and we are going to print the first 5 entries. So for that we will use the head function. So here you can see that 5 rows and 13 columns which are there have been printed. Next, if we want to print the target values also, so we have to write like this: y dot print I'm storing it in y variable, and here to write like this: wine dot target. So here you can see that the target values are also printed. So we have seen the values of the 14 samples for our 13 features by printing only 5, and on the basis of these features wine classes are made of 3, that's 0, 1 and 2. Next, what we are going to do, we are going to import the train and test split function which we do for model training, and then we are going to divide the data along with the test size. So we will split into the training data and testing data. 70% of this particular data I am used for training purpose and 30% for testing. From the training data our model learned, and from the testing data we can see that how much the model has learned. So here you can see that I have imported the model selection from sklearn, and there I have import train test split, and this is the thing we used to write for each and every model for training and splitting the data. And after that there comes the major part. We have to import the Gaussian naive Bayes model. So how we do that? We write like this: from sklearn dot naive Bayes import Gaussian NB, that is Gaussian naive Bayes. Next we are going to create a classifier. A Gaussian classifier needs to be created, and that we will fit the particular model. So that I am naming here as GNB equals to Gaussian NB, and then we will train our model. So we'll train like this: GNB, the model name, dot fit, and which data we use to fit? X train and Y train. And then what we will do? We will print a predict also. So for that we use Y predict equals to GNB dot predict function, and we predict on X test by using the data which is stored in X test. And lastly we print the Y predict. So here you can see that these are the values predicted of the data set created on the sample 0, 1 and 2. So here we have used the Gaussian model and then tested our test data. Next we are going to check the accuracy and print the confusion matrix to check how many correct assumptions or the correct features our model is guessing. So for that we simply write like this: from sklearn import matrices and then for model accuracy, how we used to like this: print accuracy score and of which data we used to do the accuracy score? The Y test data which we have given, and the Y predict which has predicted by the model. So here you can see that this is the accuracy, and lastly we are going to print the confusion matrix also. And how we used to do that? We used to simply write like this: from sklearn matrices import confusion matrix, and then we create a numpy array using the Y test and Y predict data. So here you can see that I have printed the confusion matrix also. So this is our confusion matrix, and we can see from the confusion matrix that our model has predicted a total 5 wrong values. As I have already told, the diagonal values are for correct assumption and rest are for wrong. So 2 plus 1 plus 2, 5. So 5 are wrong prediction and rest are current prediction. And we have also printed the accuracy score also. So this is how we can use Gaussian model of naive Bayes classifier for the dataset we have used here, the Wine dataset. And the particular code will be given to you in the video description. As you can see in our official website, it is completely mentioned for your reference.